Hello, this is Brother Cromar from the math department at BYU, Idaho, and now I'll be covering part 2, which is dealing with lesson 12 for inference for one mean sigma unknown. And so now I'll be talking about confidence intervals, and then I'll wrap up with checking assumptions. So first of all, here is what we did back in lesson 10. This is the formula for a confidence interval when we know the standard deviation, or we know sigma. And it's this formula where we take our sample mean, plus or minus, and this whole thing here to the right of the plus or minus sign is the margin of error. So we calculate with order of operations. We calculate this first, and then we take the margin of error and add and subtract from the mean to get our lower bound and our upper bound for a confidence interval. And the definitions are all right here. X bar is a sample mean, Z star is a critical value, sigma is the population standard deviation, and is a sample size, and everything to the right of the plus or minus sign is the margin of error. Okay. Now the critical values, the most common ones are these on the right, that are the most common critical values for the most common levels of confidence that you'll see in most industry standards. Now, as I mentioned before in the first video, how realistic is the population standard deviation being known? Well, it's not very realistic. In fact, quite often we don't know it, so we have to estimate it. So therefore, going to the next slide, this is the formula we use when we don't know the standard deviation. There's two primary differences between the two. One is that we use a t critical value instead of a z, and we use a sample standard deviation instead. Okay, the general structure is the same. Now, what I want to mention here is that, and you can, if you need to stop the recording, you can see what these definitions are. But instead of doing it by hand, regardless of the class you're in, we'll be using software to calculate our confidence intervals. So the critical value, the sample mean, all these different items will be all calculated in your software that you use, whether it's SPSS or Excel. So let's go through a couple of examples of how to calculate this confidence interval where we get a lower bound and an upper bound for a confidence interval where we don't know the standard deviation, the population standard deviation. So construct and interpret a 90% confident, a 90 and a 95% confidence interval of the population mean of body temperatures based on a random sample of 148 subjects. So we use software to get this information, and I'll get to the interpretation here in a second here. But here's, I calculated this output in SPSS, and like I said, Excel will have similar looking output. But this is where we get the numbers for the 90 and the 95% confidence interval. Okay. Now how we interpret these confidence intervals is that we are 90% confident that the true mean body temperature, just that one true mean, is between these two numbers. And if we did a 95% confidence interval, we would get these two numbers. So what happens to the width of our confidence interval when the level of confidence goes up? Well, as you can see here, the lower bound drops and the upper bound increases, so the width of our confidence interval goes up as we increase our level of confidence. Okay. Now let's go to the next problem here, and that this is the same problem that you see in the wiki and what I covered in the previous video, but now in the context of a confidence interval. The birth weight of a child is an important indicator of their neonatal health. It is important that pediatric healthcare providers track changes in the birth weight over time, so construct and interpret a 90 to 99% confidence interval for birth weight. So we use software, and so I'm going to go to the output here, and so I'm going to go to this next output. And similar to Excel, this is where on this table, the bulk of the information is where we would get our confidence interval. So this is where we would get it for the 95, and this would be for the 99. Okay. How you get into the details, you can go to the wiki. I'll be creating videos for the SPSS folks in terms of how to do it for SPSS. But how we interpret it is we say we're 95% confident that the true mean birth weight is between these two numbers, 3,115.42 and 3,436.49. And then we're 99% confident that the true mean birth weight is between these two numbers, 3,061.41 and 3,490.50. Okay, so that's how you construct and interpret a confidence interval when we're dealing with one mean standard deviation unknown. So the last thing I want to wrap up with these videos is how to check assumptions. And I'll mention checking assumptions as well as getting descriptive statistics. Now there's two items that you need to check in terms of whether or not we can do this test. First is that the sample is a simple random sample. And then either the sample, when we check our data, the sample is from a normally distributed population, so we use a QQ plot, or we find that our sample size is large enough. N greater than 30 is a guideline. So we check to see if the data is normally distributed, so we can assume that our population is normally distributed, or if we have a large sample size, we can apply the central limit theorem that says if we have a large sample size, then the distribution of sample means is normal. So if we have a large sample size, we would be fine. But if we don't, we can check a QQ plot. Now I did a QQ plot for the birth weight data. As you can see here, it's kind of wavy, so perhaps it might not be, the data may not be normally distributed, so we might have something to where it may be less skewed. But however, since we have a large enough sample size, in fact the sample size, if I go back here, the degrees of freedom for the test was 43, so our sample size was 44. So then we could say that, you could argue that since we have a large sample size that we can apply the central limit theorem to say that our distribution of sample means is normal. Now the descriptive statistics that we would ask you to put together for the one mean standard deviation unknown is for the numericals to give the sample mean and the standard deviation, and for the graph to give the histogram. You could also give a box plot as well. But if I'm going to go to the SPSS output, you would have, so for instance, here's the box plot that you can get from SPSS, and then here is a histogram. And now the numericals for the one mean standard deviation unknown are all right here for in SPSS. But you can also get the output here in SPSS using the Explore command. Now, as I mentioned, Excel, you can get the results are similar looking when you take a look at the results in Excel. And that concludes the videos for lesson 12. If you have any questions, please talk to your instructor. Thank you.